All right, so now we're going to be talking about the other special right triangle, which is a 30, 60, 90 degree triangle. And again, we have two equations that are always going to be true, and they're always going to be true only for this type of triangle. Okay, so the first equation is this. The hypotenuse is twice as long as the short leg. And then also we can compare the longer leg to the short leg and say, well, the longer leg has to be the square root of 3 times the short leg. And so I've got this question down here saying, what in the world are all these goofy square root of 3, square root of 2 types of equations? Where are they coming from? And so I want to show you how you can kind of work through this, especially later if you're trying to figure, if you don't quite remember it, if it's not given to you, and you need to figure this out on your own, there's a quick and easy way to actually solve for this. And the way to do that is by first to mark the angles. I'll list out kind of how we go about this. First, you mark the angles in a 2 by 2 by 2 equilateral triangle. Okay, if that's the case, then this is 60 degrees and this is 60 degrees, and up here is going to be 60 degrees as well, right? And now the second thing that you're going to do is you're going to take that kind of triangle and split it in half. Okay, we'll go right down the middle. It doesn't really matter which way you go. But if I split that in half, you can maybe already see how we're going to adjust some of these measurements. Okay, one side, both sides are the same, but one side is now a 30, 60, 90 degree triangle, right? Because we've got 90 degrees down here, 90 degrees down here. This is already 60 over on the side. And then up at the top, half of 60 must be 30. So we'll get rid of what we had marked as 60. Since we split it, it's 30 and 30. So that's how we actually get these two different triangles. But now we can keep going further, and we can say, instead of calling this a base of 2, we've got two different triangles. So this one's got to be 1 and this one's got to be 1. So now we're going to do Pythagorean theorem. Sorry for the sloppy handwriting. If I take this middle value, this altitude, as a squared, and I add it to b squared, so 1 squared, and I say that's equal to c squared, which is 2 squared. So a squared plus 1 squared equals 2 squared. I end up getting that a value of the square root of 3. Okay, so this altitude in here is square root of 3. So now I can think to myself, how do side lengths compare? Okay, so if I look at, let's say, the hypotenuse and compare that to the shorter leg, it's twice as long as the shorter leg, isn't it? Well, that's what this says. The hypotenuse is 2 times the shorter leg. Or if I would compare the longer leg, which is square root of 3, and compare that to the shorter leg, well, isn't that the same as the shorter leg times the square root of 3? That's where we're getting that. So both of those equations are going to hold true as long as we're dealing with a 30, 60, 90 degree triangle. And so let's do a little bit of practice on the last page of your notes having to do with that, and you'll notice I've listed not just one, but since we've got two, we might be using one or both of these depending on what we're trying to solve. Okay, so the first thing that we've got on the left-hand side is we're going to identify, do I really have a 90, 60, 30 degree triangle? And I do. I'm going to try to solve for x in this case, and x is the longer side. So since x is the longer side only comes up in one of those equations. So it makes sense to me that I'm going to use that bottom equation to begin with. So I'm going to write that out like I did before. The long side equals the short side times the square root of 3, and then plug in what I know. The long side is x. That's what I'm trying to solve for. The short side I do know is the square root of 3, and I'm multiplying it by the square root of 3. Okay, so therefore x must be square root of 3 times square root of 3 is 3. That's the value that goes right here in place of x. Okay, if I wanted to find the hypotenuse, I could. I'm not necessarily looking for that. I didn't have a value up there that I was showing that I had to. But if I was trying to find the hypotenuse, I could use that equation up here and solve for it, because the hypotenuse equals 2 times the shorter leg. Okay, since the shorter leg was square root of 3, I would say a hypotenuse is 2 times the square root of 3, and that's it. This value here is 2 times the square root of 3. Okay, so it's the same kind of concept that we were doing before, just using those equations that we know of for the certain types of triangles and just plugging in values for them. Let's try that on the right hand side. If you want to pause the video and see if you can do it on your own, go for it. Otherwise, I'm going to walk you through it now. In this case, we're trying to find x and y. Let's start by finding x. X is the short leg of this 30, 60, 90 degree triangle. I see that here and I see that here. Okay, so that maybe is a little confusing. Which one of these equations do I use? Well, if I use the top equation, I'd need to know the hypotenuse, but I don't. Right now it's just a value. If I use the bottom equation, I need to know the longer leg. That one I have. I know that one's going to be 9. Okay, so if I'm going to start by trying to solve for x, I'm going to use that bottom equation, the one that compares the longer leg to the shorter leg. So I'm going to set that one up. Longer leg equals the shorter leg times the square root of 3. And now I plug in what I know. The longer leg is 9. The shorter leg is x that I'm trying to solve for. I'm going to multiply that by the square root of 3. I'm going to divide both sides by the square root of 3. Okay, so over here I'll have 9 times the square root of, or 9 over the square root of 3 equals x. And then if I multiply, I'm going to keep x as is, but if I multiply the left side by square root of 3 over square root of 3, I'd end up having 9 times the square root of 3 over 3. I can do that because it's really the same as multiplying the whole thing by 1. And now I see I can divide 3 from top and bottom. Okay, so 3 times the square root of 3 over 1, which is just 3 times the square root of 3. Okay, so that is my value of x, which goes over here, 3 times the square root of 3. Okay, I really had to do that first. And if you think about y, the next thing I'm going to try to solve for is y, which is my hypotenuse. The only equation that I can use to solve for hypotenuse is this one. And the hypotenuse is 2 times the shorter leg. Well, I didn't have that before now. Okay, so I'm going to now use that equation, and it's okay for me to use. I'll be able to use it because now I know that the shorter leg is 3 times the square root of 3. Okay, so let's set that one up over here. The hypotenuse is 2 times the shorter leg. Running out of room here. The hypotenuse, I don't know what it is, but I'm calling it y, equals 2 times 3 times this, times the square root of 3. And now I can combine these two. Y equals 6 times the square root of 3. That is this length up here, 6 times the square root of 3. And there I've used both of those equations that go along with the 30, 60, 90 degree triangles. A reminder, you can only use these equations if you've got 30, 60, 90. Okay, and then one last note as a reminder, we kind of worked through this, but which side lengths do you actually have given to you? That's going to determine which formulas you use first, like we saw in this last problem.